In today's session, let me discuss programs for trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule, Gauss elimination method, and parabola fitting. First, let's see the program for trapezoidal rule. As we know, this is the formula for trapezoidal rule, right? F of x, integration of a to b, f of x dx is equal to h by 2 into y0 plus yn plus 2 into y1 plus y2 plus etc. So here the question is given 1 by 1 plus POW x comma 2, that means x square, that is 1 by 1 plus x square. Okay, so upper limit, lower limit, everything everything has been declared. Subinterval is declared, I is declared. Okay, and then enter the lower limit of integration, enter the upper limit of integration, enter the subintervals, and then step size, upper minus lower divided by subinterval, the value of h, and then integration f of lower plus f of upper. See this y0 plus yn. Okay, so that sum is stored in integration. That is y0 is a f of lower and yn is f of upper. Then see lower plus I into step size, that is k. Okay, based on the question only this program has been written. F of k we are getting, and then that is f of k is y1 plus y2 plus etc. and then into 2, right? So that 2 is this, and then integration is y0 plus yn, and then so you got this much. Okay, this much we got, and then integration into step size by 2. That's the last integration, final step. Integration is equal to integration into step size by 2. Step size is h. Okay, h by 2. So you got it, right? And then integration you have to print. So this is about trapezoidal rule. Same way how we have done in the question problem, same way this has been written. Next is Simpson's 1/3 rule. This is the formula for Simpson's 1/3 rule. H by 3 into y0 plus yn plus 4 into y1 plus y3 plus y5 etc. plus 2 into y2 plus y4 plus y6 etc. Right. So here there is a question. A is equal to 1 by 1 plus x square. And then there is a function. Okay, return A, answer. And then see out precision, set precision, that is up to after decimal how much you have to take, that's it. And then see enter the limits of the integration AB, enter the subintervals, a double. See we are getting the x and y coordinates. So with that only we are doing, right? So x value and y value, it is double because many values are there. And then h is equal to b minus a by n. See x of I is equal to a plus I into h, and based on that you are finding y, because this is the question. Based on the question we are getting this. So y is f of x, right? X you are getting and y is f of x. That way only we are doing the question. And then sum plus 4.0 into y of I. See this 4 into y1 plus y3 plus y5, right? So that is y of I. And then see here I is equal to 1, I less than n, I is equal to I plus 2. That means 1 and then 3, like that it will go. 3 and 5 like that. And then next for loop, see 2 to I plus 2, right? So n minus 1 is there, that is the n limit. So 2, 4, 6, 8 like that you have to get, and that value into 2. See the equation? So 2 into y2 plus y4 plus y6, right? So you are taking the array value from that. And at last h by 3, see the equation, h by 3 into y0 plus yn plus sum is this value, sum is sum plus 4.0 into y plus I, and then that is coming over here and then like that. Okay, so y0 plus yn, that is this value, and then sum is these two values, this value and this value. So that is about Simpson's rule. Okay. Now coming to Simpson's 3 by 8 rule. There's a formula for that. Same method. 1 plus 1 by x square is a question. And then here we have the difference is that a and b we are getting, n we are getting, b minus a by n you are calculating. So for Simpson's 3 by 8 rule, I percentage 3. See this in the formula, I percentage 3. That is completely divisible by 3. That's the meaning of this, right? Modulus. So this is what? 2 into, we know this is the multiples of 3, right? 3, 6, like that, 9, it will go like that. So we know how to do the problem. So here 2 into y of I, that value into y of I. That is each time it will go. First it will take y3, then y6, then y9 like that, and then multiply by 2. Okay. And then else, that is other values. Other values means y1, y2, y4 and all. That is multiplied by 3. And this sum will come over here. See, you will get the 3 into value and 2 into value. And then 3 into h by 8. See, 3 into h by 8 and then y0 plus yn. See, and then sum. Okay. So this is how Simpson's 3 by 8 rule is done. Next is Gauss elimination method. Gauss elimination method, as we know, augmented matrix you have to find, and you have to receive the augmented matrix, and then you have to find the diagonal elements, and then we have to solve it. So this is for Gauss elimination method. Next is a program for parabola fitting, and this is little bit lengthy. This is a question for equation for parabola fitting, we know, and in the case of parabola fitting program, you have to get the degree of polynomial. Okay, see n. This is the degree of polynomial. You are getting the x value, you are getting the y value, and then you are calculating. See, power you are adding it, and then you are finding the sigma, right? So that is it, sigma. Okay, and then this is build the normal matrix by storing the corresponding coefficients, and based on the matrix only we are doing this actually. And then see here, n is made n plus 1 because the Gaussian elimination method is also applicable in this. That is when this question is converted into some other format, that is with the help of the matrix only you are solving parabola fitting. Okay, and that is that thing we have written in the program. And then loop to perform the Gauss elimination. See the values of the coefficients you are getting and print the values of x0, x1 and all. Okay, so this is about parabola fitting. Hope you understood all the programs which we have discussed today. Hope it was clear. Thank you.